Assalamu alaikum warahmatullahi wabarakatuh. I'm Adnan Hassan from University Technology Malaysia. I will presenting my paper entitled Performance of EWMA and ANN-based scheme in detection of denial of service attack. This is the presentation outline. Okay, I will briefly introduce the area of research and then go to research methodology, and then move on to EWMA control chart, and then ANN-based scheme, discussion, and finally conclusion. So we know that now the manufacturing and supply chain activities are moving towards globalization, and more computers are being used in the processes and in the supply chain. And then industrial processes are being connected to internet and computer networks. So this has resulted a situation where we need a more safer computer networks for malicious attacks. Our computer systems are exposed to potential dangerous attacks. This might create a catastrophic disturbance to the operations. So the computer networks are vulnerable to malicious attacks, whereas the volume of traffic are increasing exponentially. So our study will focus on denial of service attacks. Actually, there are many other types of attacks, but our focus is only denial of service, where the perpetrator attempts to intrude the computer network by disturbing a host connected to the internet or computer networks. So as a result, it will create excessive loading and unnecessary requests for service from the computer system. There has been a lot of work in this area, okay, but however, huge challenges still exist. So more works are needed to produce more effective and reliable intrusion detection schemes. And also the dynamic nature of the computer attacks generate new variants of type of attacks. So based on our review, there has been limited work focusing on EWMA for feature selection and detection of malicious computer network traffic. So this motivated us to investigate into this area. Okay, the objective of our study is to investigate EWMA for feature selection and detection of malicious computer network traffic. And second objective is to evaluate the effectiveness of ANN or artificial neural network-based scheme with EWMA statistics on the selected features as input to the artificial neural network scheme. Okay, our research methodology is divided into 3 stages. The first one is data source and feature selection, where we use histogram and time series plot. And then we investigate using EWMA control chart for DOS detection. And then the third stage is using artificial neural network for DOS or denial of service detection. And we make comparison in terms of the performance for these 2 alternative schemes. Okay, our data source was coming from KDD Cup99, which is publicly available. And actually, this is a benchmark dataset for those in this computer security area. And only 10% of data was used in our study. And the data actually comprised of 41 network traffic features, which was categorized into 4 classes, okay, in addition to normal traffic data. Okay, as mentioned earlier, our focus is only denial of service attack category. Okay, in the development of EWMA scheme, okay, so we use EWMA statistics, which is represented here as Z, okay, and lambda is the smoothing constant. And then we use the control limit as shown here. These are the standard formula used in EWMA control chart. Okay, and the performance measure of the schemes are based on our average run length, which is we measure how quick or how fast it is to detect an attack. And also we use false alarm and then accuracy as a performance measure of our alternative scheme. Okay, why we use EWMA ANN? Okay, EWMA actually is very well established statistical process control techniques, has been proven for monitoring process variation in manufacturing processes, and also it does not require normally normality, normally distributed data. So that's the advantage of using EWMA. And EWMA also capable to detect small shift. And why we use MLP, multi-layer perceptron, for artificial neural network. So this techniques has been proven effective in classification, in pattern recognition, has been used in banking fraud detection, biometric verification, and many other areas. So for the purpose of comparing the effectiveness of features, okay, we use histogram where we graphically can see the difference between normal traffic and attack traffics. So only those features out of 41 features, we select features that has the capability to differentiate between normal traffic and attack traffic. And also we use time series plot to see the differences between normal traffic and attack traffic. If you see in here, is one example of time series plot where we plot feature H, the normal traffics, and then followed by attack traffics. So you can see a significant difference in terms of behavior of the time series there. So out of 41 features from the data set, we only selected 8 features as listed here. We label as A, B, C, and so on. So before we proceed using EWMA for monitoring purpose, we have to develop what we call it normal traffic profile. The procedure are as listed here. Okay, so we need to select the significant features. We do the training. We design the EWMA control charting by selecting a proper values for lambda and L. We calculate the Z value, and then we determine the target mean and the standard deviation. And then we establish the control limits, upper control limit and lower control limit. So, and then we get these normal traffic profiles. And then we use this normal traffic profile for monitoring the unknown the unknown traffics. Okay, this is an example of how we use EWMA in the monitoring of traffics. So we start with normal traffics and then followed by attack traffics. We can see here it's a very clearly we can detect there has been attacks after sample number 60. Okay, in terms of performance, we make comparison based on false alarm rate, FAR, and average run length for all the 8 selected features. So you can see that features A, the lower value shows a better performance. Okay, feature A and feature B are relatively better performance compared to feature C, D, E, F, and G from the measure of false alarm rate. Okay, H also good in terms of false alarm rate. Low value means better. For average run length, we see that A is good for less false alarm, but it has a longer average run length to be detected. Okay, we can see that C and D are good in average run length, but they have high false alarm. So there is a contradicting performance in terms of FAR and ARL for some features here. Okay, in terms of ANN scheme, so we use MLP, multi-layer perceptron neural network, and our network structure was 8 nodes for input layer, 20 for hidden layer, and 1 for output layer. And we use supervised learning based on Leeuwenberg-Marquardt algorithm. And this ANN scheme was implemented in MATLAB using ANN toolbox. So we make a comparison in terms of performance using 2 data sets, 2 testing sets. So we found out that the results are moderate and quite promising in terms of accuracy, okay, sensitivity and specificity. Of course, there is still a need to improve the performance. So more fine-tuning are needed. Okay, for the discussion here, the univariate EWMA control chart techniques was able to monitor one individual features at any distance, but we can see that ANN was more accommodating and capable to concurrently employ all the 8 features. This is due to the nature of ANN and limitation in univariate EWMA only are able to use only one features at one time. So the results suggest that false alarm rate for EWMA scheme varies widely depending on the specific features. So we can see that features A score relatively good in terms of false alarm rates, but poorer ARL, okay, compared to feature B, which is lock-in features with false alarm rate only 7%, but ARL is 3 only. Okay, so we can see contradicting performance in terms of 2 different measures there. ANN-based schemes score a moderate and relatively consistent false alarm rate performance, okay, between 17.8 to 19.3%. So EWMA scheme has capability to rapidly detect sudden change, especially for feature C and D. Okay, however, this feature resulted in high false alarm. Okay, we made the comparison between EWMA and ANN. We can see that, as I mentioned earlier, the performance in terms of false alarm rates, okay, among the features varies widely. Okay, for ANN, the performance we can say is moderate, okay, and it is more consistent. Of course, because we use all the 8 features concurrently. We make a comparison of our scheme with another researcher, Ahmad, and we notice that our performance in terms of accuracy is comparable. Of course, we still need to improve in terms of false alarm rate. Okay. Okay, as conclusion, we can see that EWMA and ANN scheme are promising procedures for detection of malicious computer network data, computer network traffics, and EWMA scheme has selective effectiveness where some features are able to give rapid detection, which is with a low ARL 1 but high false alarm. Okay, log-in is the best features among the investigated features, and ANN-based scheme with 8 selected features score relatively moderate performance, okay, with false alarm rates between 17.8 until 19.3 and accuracy between 18.7 to 82.3%. So ANN-based scheme was more accommodating in handling variability in traffic data. So our suggestion for further work is possible for future research is to investigate into multivariate EWMA and also to explore adaptive scheme for addressing dynamic and changing computer network environment, and also possible to extend this investigation into cloud network and IoT devices. We would like to acknowledge University Technology Malaysia and Research Management Center for making this presentation possible with financial support. And thank you very much for your interest in listening to my presentation. Assalamualaikum warahmatullahi wabarakatuh.